So in this chapter, one of the things we're working on a lot is motion. And the three things that we're really focusing on are position, velocity, and acceleration. And so these three things are all interrelated to each other. It turns out that when you have a position function, if you derive it once, it's velocity. So velocity is really x prime of t, the derivative of position. And acceleration is just that next derivative up. So if you took velocity and you found v prime of t, that's one derivative up. That gives you acceleration, which technically is the same as x double prime of t. It's two derivatives up from position. So the relationship that we know is that you go one derivative up from position and you get velocity. You go two derivatives up and you get acceleration. Now the classic problems that we're going to be working on in class are these ones where something goes up and something goes down. So a ball or a rock or something gets thrown in the air and then lands on the ground. And when that happens, you usually get some sort of an equation. So here's a scenario. A ball is thrown upwards and its position is given in feet by x of t equals 128 t minus 16t squared, where t is measured in seconds. Now, when I see this problem, I immediately kind of want to graph it. Like, I'm already thinking in my head a little bit about what would this graph look like if I had an xy axis. And I know it's a ball being thrown in the air. So I'm kind of envisioning that the ball is going to start here, go up in the air, and then land on the ground. Common sense kind of tells me that. Well, think about the equation that came with this thing. X of t equals 128 minus 16t squared. That thing, that's a t squared graph, an upside down parabola graph. So this graph right here must be the x of t equation. And of course you could graph it in your calculator and get a really precise looking upside down parabola. But I'm guessing that this thing up here, you know, it's down here. It's this upside down parabola graph. So we're going to ask some series of questions about this ball being thrown in the air. Question A. When does the ball reach its maximum height? When does the ball reach its maximum height? That's our first question. So here's what I'm thinking. If I'm studying max height, I can tell in my picture that right up at the top of my graph, that's the max height right there. That's how far the ball goes. So I want to know, where is that? Actually, I actually want to know, when is that? So when will the ball? So think about it. The x-axis here is really the time axis. And we're measuring this thing in, let's go back and read it. What was it? It was in seconds and feet. So we have feet and seconds that we're focusing on. So down here, these must be the seconds. And over on the side here, these must be the feet. So to figure out when the max height occurs, I'm looking at the top of this parabola thinking, you know what, it's a unique location. It has a slope of 0. So when I see it, I'm thinking, you know, slope of 0. Well, what calculates slope generally for us? The derivative. So why don't we take this equation down below down here, and why don't we find h prime of t? Let's derive this thing. 128t minus 16t squared is just a power rule problem. It's going to be 128. Minus 16 times 2 is 32t. There's my derivative equation. Well, we want a slope up here at the top equal to 0. So if we want a slope of 0, we actually want the derivative to equal 0. We want 128 minus 32t. So we're going to write this out. 128 minus 32t to equal 0. And now I'm going to solve for t. Let's figure out, what does t equal? And that's going to be just doing some basic algebra. So 128, we're going to add the 32 to the other side and divide it. And we're going to get time is equal to 4. T is equal to 4. Which means on my graph up here, this maximum height that's happening down the middle here is happening at 4 seconds. So to answer my question here, when does the ball reach its maximum height? It is at a max height at time equals 4 seconds. That's when it gets to the top of the graph. So let's ask ourselves another question here. The next question is, what is the maximum height? How high up in the air does the ball get? So now that I know that this is occurring at 4 seconds, what I want to now know is this max height, where is it over on the y-axis? Over here. Where is this point? So that's my new question mark. Let's figure out how high in the air this is. So I'm kind of backtracking and realizing I don't need a derivative to figure this out. I already have the equation for this curve. This orange upside down parabola is x of t equals 128t minus 16t squared. So what I really want to know is, what is the height of the ball at 4 seconds? Because that's the maximum here at 4. So what is the height at 4? Well, I'll plug it in. 128 times 4, don't need the derivative for this, minus 16 times 4 squared. And now it's just a matter of doing some math. So we're going to plug this all in. You can do it in your head or do it in a calculator. And we're going to end up getting 256. That means over on my graph where that question mark is, let's erase that question mark. That now means that this is at 256. And remember what the units are, 256 feet in the air. So this is 256 feet. I'm going to write that down below down here. So at 4 seconds, the ball is 256 feet up in the air. All right, let's ask another question. So question C, letter C. When will the ball hit the ground? When will the ball hit the ground? So going back to my graph here, we know that the ball got up to a max height at 4 seconds, but hitting the ground is a different story. The ball starts at the ground and it ends at the ground. So we know it starts at 0. What we want to know is, when does it land? Common sense tells me that if it took 4 seconds to go up, it's probably going to take 4 seconds to go down. But we need to prove that mathematically. So I want to know, where is this point at? And to figure it out, I already know that the equation for this graph is h of t. So really, all I got to do is take this h of t function down here and set it equal to 0. 0 is the ground. Set 0 equal to 128t minus 16t squared. And so I'm going to solve this by doing a little factoring. Let's divide a t out of this problem. So if we divide the t out, it might be easier. In fact, if we want to make it super easy, we could probably divide a 16t out of here. If we divide by 16, 128 divided by 16 is 8. So we have 8 minus, we'd still have a t. So by factoring this, I know I now have 16t is equal to 0, and 8 minus t is equal to 0, which is going to give me two answers. We're going to get time is equal to 0 and time is equal to 8. Two answers make sense because when I'm looking over here at my graph, it started at time equals 0, it lands at time equals 8. So I'm totally getting why we got these two answers. Time equals 0 seconds, time equals 8 seconds match up to these things. So to answer the actual question, I'm not going to use both of the 0 and the 8, so I'm going to uncircle those. When will the ball hit the ground? Well, it's not going to hit the ground at 0. That's when it starts. It's going to hit the ground at 8. So my final answer is time equals 8 seconds. That's when the ball hits the ground. Takes 4 seconds to go up to the top. Takes 4 seconds to land back down on the ground. So one last final question. Question D, what is the velocity of the ball when it hits the ground? So right here, at 8 seconds, the ball is hitting the ground. We want to know, how fast is it hitting the ground? What's the velocity? So that's a moment in time that we want to know the velocity. We're really curious, what is the velocity at time equals 8 seconds? That's what this question is asking. We're not going to be able to figure that out until we know what v of t is equal to. And v of t is the derivative of position, h prime of t. So our job is to find h prime using the power rule. We kind of did this earlier. It was 128 minus 16 times 2 is 32t. Now I'm going to go and do what I wanted to figure out earlier. I wanted to figure out what v of 8 was. So what I'm going to do is underneath, I'm going to write v of 8 equals, and I'm basically going to plug 8 into here, into the t. So I'm going to do 128 minus 32 times 8. And now I got to do some math. So v of 8 equals 128 minus 32 times 8. That's going to be a negative number. That's actually interesting. That's going to be negative 128. That's going to be my answer, negative 128. So now units, this is how fast the ball hits the ground. This is the velocity. So when I write my units for this one, I'm envisioning it's going to be in feet per second. This is how fast the ball hits the ground. Feet per second. So let's circle this thing. It's a little messy. It looks like red and green Christmas colors here. And I think the answer makes a lot of sense because it's negative, and it's negative because the ball is going downwards in the air. So I would expect a negative velocity. So I'm actually going to write a little statement down here. I'm going to write the ball travels negative 128 feet per second when it hits the ground. When it hits the ground. And this answer makes a lot of sense to me, because if it had been positive 128, I would have expected the ball to be going up instead of down. Down makes sense. So it travels 128 feet per second when it hits the ground. Alright, I hope that helps. We're going to keep working on this in class.